Hi all. In today's session, we are going to make use of Google Cloud Platform to perform or solve an image classification problem. So this is in continuation with respect to the image classification problem, which was performed in the earlier lecture by making use of Keras and building a corresponding neural network. Towards the end of the lecture, we realized that the performance of the model has not been that great. So let's see how GCP performs in this aspect, where it is a kind of plug and play API we have in GCP, which goes by the name AutoML Vision to perform the image classification. So first step, kindly create an account in the Google Cloud Platform. And once you log in, this is the landing page of GCP. So this is the GCP dashboard. And in the search bar, just search for Vision and select the Vision product. And it kind of opens up three widgets. One is the AutoML Vision, which we are going to make use of today for performing the image classification. And there are two other APIs called the Vision API and Vision Product Search. So just select the AutoML Vision. And this is the landing page. So this is essentially where we kind of upload the data set to build a model. So the data set we are going to make use of is the Chessman image dataset, which was used in the earlier lecture. Just kindly download the directory. And once we have it in place, the first step is just select a new dataset and give a name to it. Let me give it the name as Chess dataset today. And once we give the dataset name, we have to provide the model objective. The model objective from the GCP's perspective is in the sense whether we are going to perform a single label classification problem, or we are going to solve a multi-label classification, or we are going to do an object identification, as in the case of videos or photos where we try to identify objects. So as seen as seen in the previous lecture, we have 6 labels of chess pieces, the king, queen, rook, etc. So it's a multi-label classification problem. And once we select it, we're going to press create dataset. So and once the dataset is created, we enter the next step where we have to upload the images on which the model has to be trained to classify them. So as seen here, there are multiple tabs for this particular dataset which we created: the import, images, train, etc. So the first step is to import the required data. So upload the images from the computer and quickly select the files. One thing to be noted is once we download the dataset, so these are the different labeled folders which we have. For example, in the Bishop folder, we have only the Bishop images. So what we need to do is we need to zip the master folder and upload that particular zip folder into the GCP environment. So this particular zip folder has to be stored in a particular location which goes by the name of bucket. So GCP requests us to create a bucket to store this particular images. So just select create new bucket, and let's give a name as test123 is the bucket name on which the images are to be stored. And once we select continue, so I have used it already. Let me just change the name. And once the bucket is created, we need to specify the region on where this particular cloud instance will be hosted to store it. So as seen here, there are multiple options of multi-region, dual region, or region. For a multi-label image classification problem in GCP, always select the region as US Central 1 Iowa. Please kindly make a note that for a multi-label classification problem using GCP's AutoML Vision, always the region has to be set to US Central 1 Iowa. And the rest of the options can be selected as default as it is. And the moment you press create, a new bucket is created, and select that bucket. And the moment you press continue, what happens is that entire zip fold images, they get uploaded into this particular storage. So depending upon the internet speed, it does take some time to upload close to 550 images we have in place. So let me quickly show how this particular images tab changes once we upload the data. So let me quickly open the other data set. I mean, essentially the same data set which I had uploaded earlier, the 550 images one. So once we open it, so this is the images tab which we have. So literally all the images are uploaded with the different label names. For example, if I filter out the bishop alone, I'll be receiving on, I'll be seeing only the bishop images. So, okay, now the base data set which is needed for training the model to learn the classification of these different chess pieces are uploaded, and jump to the train tab. So the first time when you enter this particular phase, you will not be having the widget, and simply select train new model. So it does take considerable amount of time. For example, for this 550 images we have, it took about 1.5 hours to train the model. But the best part is once you select train the model, we can leave the system. We'll be receiving an email communication from Google stating that the training of the model has been complete. So once we receive that mail, we can come back to this particular page and see the performance. So as seen here, for this particular model, we do have a precision and recall of greater than 90%, which is extremely good because in our previous exercise with Keras, the performance of the model has not been that great. So we have 550 images and we have excellent precision and recall. We can also see the full evaluation, including confusion metrics in GCP. So let me quickly select the full evaluation, which takes me to the evaluate tab. So as seen here, out of the 550 images, 496 images have been used for training and 54 are used for testing. And this is the corresponding precision and recall curve we have here. And the best part is the confusion metrics. So as seen here, between the true label and predicted label, we have the pawns are 100% predicted perfectly, whereas the queen, 88% of them have been predicted correctly as queens. However, 13%, close to 13% have been predicted as kings. So we do have the confusion metrics as well in GCP straight away. On top of that, the best part is the test and use, where we can kind of deploy the model straight away in GCP if we are satisfied with the model performance. So in this way, by not actually building the model end to end, GCP provides us an out-of-the-box solution which goes by the name AutoML Vision, where we just upload the required data set on which the model has to be trained for the classification exercise, and inform the AutoML Vision the objective, model objective, whether it's a single label classification or a multi-label classification. And the moment we press train model, we have the state-of-the-art performance, which is coming as the output. Thank you.